Okay, let's get into it. For today's deep dive, we're unpacking the logistics of sending satellite signals over really, really long distances.
Right. And we're looking at some very specific source material on L-band RF over fiber solutions.
We are. It's all from the HDTV Supply site. They call themselves the 25-year global home for audio and video products.
They've even got that 833 Wolfpack phone number.
They do. But what's really interesting is the problem this tech solves. So why does a product like this even need to exist?
Well, it comes down to a fundamental limitation, a bottleneck. And that's standard coaxial cable.
The copper stuff.
Exactly. When you're dealing with L-band RF signals, which is what satellites use, coax it runs out of steam very quickly.
How quickly?
You're talking maybe a few hundred feet, a couple hundred feet max, before the signal just degrades into static. It becomes useless.
Okay, so that's the wall you hit, a few hundred feet. But the solution we're looking at, this Thor Broadcast kit, it claims a range of over 50 miles.
It does. The F-LBAND-TxRx kit, it's a transmitter and receiver pair.
So how do you get from, say, 300 feet to 50 miles? That's not just an improvement, that's a whole different reality.
It is. The breakthrough is converting the signal. You're taking electrical pulses from the coax and turning them into pulses of light. And that light travels down an optical fiber.
And fiber doesn't have that same signal loss problem.
Not even close. It basically eliminates that resistive loss you get with copper. This lets you put a satellite antenna, say, 10 miles away from your broadcast center and get a perfect signal.
That's incredible. It completely changes how you design a broadcast facility.
It absolutely does. And it does it while keeping all the, the professional requirements intact. It's not just a dumb signal pipe.
What do you mean? It handles the full frequency range, right?
Yeah.
The 45 to 2800 megahertz.
It does, but it's more than that. The system is smart. It actually manages the power for the satellite dish itself.
So power is going back up the line to the dish.
Yes, exactly. It provides what's called LNB power. The LNB is the little receiver on the arm of the dish. This kit sends it 13 or 18 volts DC.
And it also sends control signals. I saw mention of a 22 kilohertz tone.
That's right, and that is absolutely critical. That tone is basically a command.
A command for what?
It tells the LNB to shift its polarity. So to switch between, say, horizontal and vertical signals, that's how you tune into different sets of channels. Without that tone, you'd be stuck.
So the fiber has to carry the massive data stream and this tiny control signal perfectly.
Simultaneously. And it does.
The sources also mentioned something about multicasting using PLC optical splitters.
Right, PLC, planar light wave circuit. It's a passive device. You can take that one fiber coming from your remote dish
And split it.
and split the light signal to multiple destinations without any new electronics. That's huge for broadcast head-ends, where one feed needs to go to dozens of places for processing.
So this is what makes those big remote satellite farms possible. For uplink, downlink, DBS services, all of it.
It just removes the constraint of proximity. Your dish no longer has to be on the roof of the building.
Okay, so let's wrap up with a final thought for you to consider. Something pulled from the deep specs.
Go for it.
It's about the physical connection. Even with all this amazing tech, the connector you use is critical. The unit requires something called an STEPC connector.
The angle polish connector.
Exactly. And the specs warn that if your fiber cable has a flat connector, like a more common SCPC, you have to use a special jumper to convert it.
Because of light reflection, right.
Right. That tiny angle on the connector face prevents light from bouncing back up the fiber. Without it, a microscopic reflection at the final connection point could kill your entire 50-mile crystal clear signal.
So the whole system can fail because of one flat surface.
One tiny flat surface. Something to think about.